Hello everyone, good morning. My name is Vijay Thope and I am, as Sif said, I'm a senior solution architect with AWS and I've been supporting a lot of our automotive customers in the metro Detroit area. Okay, so this use case is more about how we can leverage GenAI, which is our current hot topic, which everybody is talking about, and how it will fit in the auto industry, where it fits exactly in the auto industry. Before I dive deep on the use case, I'm going to talk about a flywheel or a customer vehicle customer loop, which where GenAI will fit for some of these use cases. You can see in the from the center, it is more about where the vehicles are manufactured by the manufacturer's OEM. Their GenAI will fit in some of the use cases around equipment breakdown or supply chain or other areas where it will fit. And from there, when the vehicle is sold by the dealership, and you can enable shopping experience using GenAI, using chatbots, as well as what do you call it, like predicting some of the user choices based upon different options with the vehicle options and the data along with the data about each of the vehicles. And then the next variation we can think of is once the vehicle is with the customer, what are the different experience the customer can take advantage using GenAI, especially around personalization and efficiency. Efficiency is about different uh, day-to-day routine tasks as well as tasks that can be leveraged using GenAI. And then from there, if when a vehicle needs to get into service or repair, automotive dealerships also can leverage GenAI, especially for parts availability, service booking, appointments, and then also interacting with the customer through chatbot. And then from there, if you go to the deep into the dealership where technicians service the vehicle, they need a lot of information about the vehicle because of the complexity that is coming in the vehicle, how to repair, using the documentation that's come from the OEM on diagnostic codes, wiring diagrams, and complexities around it. And also with techs evolving, how they can collaborate across other techs within the industry to get responses quickly on complex problems. So you can imagine this whole thing is a cyclic loop which continues on where GenAI is basically playing a huge role in the journey. So coming back to the use case, so what we have picked is the efficiency and personalization aspect of the use case is what this whole smart vehicle companion app is all about. The app is basically if you're planning for a journey and a long travel and you need to plan out different aspects, especially food, sightseeing, where to stay. If you are using an electric vehicle, you need to charge at different charging stations, or if it is a fuel based upon the route you are going out, as well as additional factors like weather, ratings of restaurant or hotel chain, and then also sightseeing options with reviews, basically. So all those different experience how GenAI can help with this use case is what this demonstration is about. And also there is a reference architecture I'll walk through along with the demo. So in order for this whole use case to be more connected, I think the first topic we talked about connected mobility, which is really connectivity data. So since modern vehicles are connected with modem and telemetry information, you can use the data along, especially on what is the fuel level, how much charge this vehicle can take, how much charge is left, and what is the tire pressure, cabin temperature. These are like some of the elements along with your, of course, the location information. And then the second aspect is your profiling data, especially a lot of the OEMs provide mobile apps with where the user can configure their profile about the food choices, coffee or the Starbucks example or McDonald's preferences, and your calendar, for example, and then also other information around like extra information around your customer point of interest. And the driving pattern is again data that you can pulled from the connected mobility data, especially on the speed at which you drive, and then the driving behavior and the routes, basically. So these are the other data elements. And then the third data set is really, again, the third-party data information from information around the route, where the different restaurants you have, point of interest area, feedback, reviews, and then, of course, feature weather data, traffic data, and then charging pattern. So you can think of those are the additional data enablers, and probably more to come. So these all together will help in making decisions as well, along with the with GenAI taking advantage of those standard LLM models, along with the third-party data, as well as these additional data elements. So as far as an user experience, you can think of the user experience either through a mobile app or from an app through an infotainment screen. And then you can, once the user provides some basic information about where he's planning to go, and all those additional information is pulled from the data set that we just saw previous screen with the profile, and then the app basically kind of gives you a route map with the different options around where to stop, where to charge, and also if you want to stay overnight, where to stay at the house. Those are the elements that will be shown, part of the user experience. So yeah, this is a reference architecture that we've developed to showcase how the different pieces of AWS services come in play, and the libraries that we have used for this use case, and how the whole end-to-end experience will take advantage of all these different services. On the left is basically the customer having driving a vehicle which has a voice-enabled app, like Karen mentioned about Alexa enabled app, or maybe your mobile app which has a regular mobile app with this experience enabled. And then you can, once you say the destination that you're planning to drive to, then the information is fed into the backend of AWS through gateway, Amazon API gateway, and then which is then goes into Lambda function, which is really an leveraging a LangChain, which is our orchestration tool, which then makes those decisions by passing those prompts to the LLM model, and then from there it kinds of picks in all the different sub tools, we call it. Each tool basically is, one is a restaurant tool, one is a charging station, one is like a hotel information. Those are the different sub tools that it will orchestrate, coordinating with the LLM by passing the prompt information. And then also on the back end, it leverages some of the connected mobility data that is coming from the vehicle, especially the current state of charge, and also the profile information coming from the back end that is also fed to the decision making process, along with the third party information. For this demo, we have used Amazon Lambda along with the Bedrock service, which is really the Bedrock service is the enabler for this GenAI. Along with that, we have used Amazon location service to showcase the demonstration. And from a RAG, which is really your data set that is getting integrated, especially around food chain, restaurant, charging station, that is coming from a PG vector data store that we have loaded for some of the states from the open source data. And all these together is basically how this demonstration, I'm going to walk through that. And then part of the demonstration, I'll also talk about some of the backend stuff behind the scene that's going on, so you get an idea how this reference architecture can be realized with GenAI. So let me switch over to the demonstration screen. So this is basically a simple Node.js app we have developed for this demonstration. It takes two input parameters from starting location and the destination. And then on the right side, these are the different profiling data that I was talking about, like what is your food preference, and then whether you are going with family, is it a car or a truck, and then purpose of the travel, is it a meeting or a leisure or maybe a function. At the bottom, what we have pulled in is, imagine if it is coming from connected vehicle data. We kind of showing the car range that the charge has in the electric vehicle, so that it can use those information to calculate the best routing option and then the charging options available. For this demonstration, I've used Dallas as your starting point and then driving to Austin, Texas. So when I click route, this is where it is going to start taking the prompt that is fed into this Lambda function, orchestration function, and then along with that, it is going to use all the different tools, sub tools around all these food option, leisure options, and so on. And then it'll come out with a comprehensive response, laying out a map from start to end. So I'm going to click route. While it is doing it, I'm going to talk through the behind the scene what is happening. So once I hit the route, generate route, we have a prompt defined in this backend. It's just a sample prompt, which is an NLP text-based prompt, which takes all these different text information, and then I'm also feeding the runtime information, which is our location, starting location, destination. And like I said, once the prompt is fed, it goes to the LangChain agent orchestration, and which in turn calls the different sub functions or tools, we call it, to get the use the traveler preference and then calculate the route, telemetry, which is the vehicle data, third party data like weather, along with that driving range and the available charging stations, all those things. It will bring those data based upon the driving range and the footsteps. And then the outcome will be more a data set that the LLM constructs, and it'll just given a sample of a data set like a JSON, how it shows it gives you a data set around Starbucks in this example, but there's more data to it. So when we go back to the screen, you will see that I gave Dallas and Austin, and then it shows you a Starbucks location, and then also behind the scene there is the charging point, which is also behind this map, and then food stop option, and then hotel, which is really your where to stay if you want to stay overnight for that trip. So all these informations are all basically shown both in the map as well as on the right side, the start and end of it. So this is basically an end-to-end experience from a user leveraging GenAI, and to show the demonstration. So another demonstration pulled in is like, if we give a different route and how the experience looks like for that route from Dallas to Houston. In that case, the distance is longer. There's more coffee stops and then charging stations, and then and all those information are all also laid out as well. So just to give you the flavor of demonstration across two different route patterns. So coming back to the flow, so once this is where the experience is. So let's talk about a little bit about GenAI and how it is helping this whole demonstration, especially the use case. So GenAI as a GenAI stack is basically, you can think of as 3-layer stack. You can think about a three macro layer stack. One is the bottom layer is where the infrastructure, which is where you are using the infrastructure to train your foundation models with the data that you have. And then the middle layer is where the tools available, especially the different tools that we talked about. And then the top layer is where the applications that leverage the large language model and the foundation model, which is really the different foundation models that is available for choice, which I'll talk about, along with the tools around it. So that is how the 3-layer stack is broken down. And to go further deep dive into the stack, the bottom layer especially is talking about your GPUs, inferentia, and all the different infrastructure available for to train those models, especially the foundation models, because these are large models that is going to use large data sets. So based upon the type of data, whether it's structured data or unstructured data, images or videos, then you need to use the right infrastructure. And coming to the tools, like I said, Amazon Bedrock is your one of the tools, along with the agents like LangChain agent and then Bedrock agent. There are different agents available as well as customization available with for the rack purpose, like RDS data stores, like and so on. And on the top is really some of the services that we have in AWS around Amazon Q, which is really, again, an interactive tool for different use cases like chatbot and then quick insight, as well as Amazon Connect. Code Whisper is more for developers to help automate, develop, write code based upon the prompts you provide. So we have the entire stack available. And to go further deep dive into Bedrock, Bedrock is really your easiest way to build and scale your GenAI applications with the different LLMs available uh, in the AWS stack, along with third-party models as well. So, for example, there are these are the top foundation models that are offered in the AWS platform, like A121 Labs. Amazon has its own models, Anthropic, which is really the cloud model that is used for this use case, and Cohere, Meta, and Stability AI. And then in fact, we had recent announcement about around new models that Amazon went live recently as well. You can find out in the AWS website. And of course, along with the data, you want to have guardrails and security and privacy as well. So those are all available as well. And these are the different broad choice of models that are offered in the AWS platform. You can, when you go to the Bedrock, when you select Bedrock, users have the choice to pick the different models based upon the use case and based upon uh, their needs and also the data, and also whether you want to use a text-based or a chat or maybe a graphical-based use cases. So different use cases and different models available, choices available, so that one size does not fit all. So the users have the choices to pick the right models. And then, of course, security and privacy is a key one that we are taking seriously as well. So the customer's data is not used to train this model. None of these customers' data, all data is encrypted, both in transit and rest. And then uh, data that are used to customize model remain within your VPC. For example, if OEM wants to train data with their deal with their customer data, they can train it and then develop their own LLMs within that VPC. And of course, as from a standard perspective, GDPR and HIPAA compliant as well. Okay, so with that, I've given a feel of what generative AI is about, and everything that you need to accelerate your journey, especially from what type of application, what type of data, and also the infrastructure, and then also improve productivity. So you can think of all those pillars that are needed for your GenAI journey. We have all those pillars available as part of the AWS platform. So definitely take advantage of that. Of course, the key aspect is in order for you to come out of experience the GenAI journey, select the right use case for that, for the need, and that will help you to realize all these different components and services that I just talked about for you to prove out the concept as well as deploy those experiences in your customers stack, especially either in vehicle or cloud or mobile apps or maybe in the factory as well. So before I finish my thought, I mean, these are the different materials to read through, and then there are different skill builders, courses, training courses available that you can go through and familiarize yourself with GenAI. Of course, talk to your teams and then definitely reach out to the accounts that you are working with. So definitely we can um, understand your use case and then help to realize those use cases. Thanks, everyone. Asif, over to you. Q&A.
Thanks, Vijay. Yeah, I see that Siva raised his hand. So can somebody unmute Siva? I will. Yeah, Mohan, can you unmute Siva?
Thank you for sharing, Vijay. I have a couple of questions uh, on the solution that you demoed.
Mhm.
Was it went live with any of the OEMs? If so, can you share? That's one.
So, yeah, so right now this use case is something we are socializing with some of the customers because GenAI is new and how to realize a use case with GenAI. That is what this use case is trying to help to bridge the gap with the customers. So we're still working on it.
Got it. And my second question is, I think you touched upon the enterprise security, right? And you have some FMs, but you need to feed those FMs with or customize those FMs with your data. So I think where are those barriers defined, like in terms of protecting uh, the customer's data versus the generalized data that is available for FMs?
Okay, so we have to see it twofold. Foundation models are things that are trained using the data set that is available in the industry for that particular for a variety of use cases. And then when it comes to customer data is something tied to your customer that is meant for that use case. So that is where the RAG comes in, where for this example demonstration, what we have done is used a vector store where we have created those that additional data elements that is used along with the LLM model that is coming out with what the cloud model, and then combining it a part of the whole orchestration. So for the most part, if the LLM is LLM that you are using from the industry like Anthropic, which is what we like Claude is used, there is your customer data is not fed there. Your customer data is only used at runtime using the RAG that can be orchestrated along with the large language model. Hope it helps. I mean, if we need deep dive, we can explain the difference where the customer data comes in versus the public data that we is used by the LLM models.
Yeah, I think that will help. I don't know whether I think we have only 4 more minutes. I respect others. If you have anything that you can share, or I think that would really help.
Sure. Yeah, we can connect offline.
Thank you.
Sure. So, Vijay, I can expand on the Siva's question. Like, if user want or customer want to be more predictable, more reliable, or more what other element play a role in this kind of reference architecture or this kind of thing? You mentioned connected mobility. Other than that,
Yeah. So yeah, I think so. Yeah. Thanks, Asif. So connected mobility is data that is coming from the vehicle is one factor, and then the data that is used for the demonstration, especially around restaurant information, charging station information, or food choices, those are all your third-party data, external data that is fed into it, and also your profiling data. If your profile data is basically, for example, you have different preference on food choices, those data are not part of the LLM, but those data will be used by the orchestration layer, which is the lang chain, to use that information to feed it to come out with a response. So basically, LLM plus customer data plus third-party data, it's all together is what you are getting the response. If you don't feed the customer preferences, then probably it will give you general information, like general recommendation. But if you give a target and like I want my preference is Starbucks, that data is fed. So the orchestration filters that are not non-Starbucks and then only takes the Starbucks information and shows it to you. So that is how the customer specific targeted information is used during the decision process.
all right. Thank you very much, Vijay.